Today we're going to learn about Lewis models. Lewis models will show how the atoms and electrons are arranged in covalent atoms. What is the stable number of electrons? We're going to learn about something called the duet rule. And the duet rule is atoms are stable with two valence electrons. Hydrogen forms stable molecules when it shares only two electrons. Helium already has two valence electrons and is stable because it's 1s2 is filled. Here's an example of a duet. Consider hydrogen, H2. It's the simplest molecule. Hydrogen atom has a single valence electron. Hydrogen is stable with two shared electrons. In the drawing, we'll show two dots, and oftentimes we'll use a line to represent the shared pair. So here's a hydrogen atom, combines with another hydrogen atom, both having one electron, and it forms an H2, which has H2, and the molecule has a duet. So by sharing it, both hydrogens are able to get a duet. And that's a shared pair of electrons. Okay, what's the stable number of electrons? A duet rule says atoms are stable with two valence electrons. Octet, which is most things, are stable when they have 8 valence electrons. That's when they're filling their s and p outer orbitals. Carbon, nitrogen, oxygen, fluorine always follow the octet rule with no exceptions. And the majority of the time, silicon, phosphorus, sulfur, chlorine, selenium, bromine, iodine will be following it most of the time. Octet. Most molecules, such as F2, need 8 valence electrons to be stable. Here's fluorine with 7, combines with another fluorine with 7, and then you get F2. And the S should be moved over a little bit in the drawing, and that's a molecule of F2. Or you could draw it with the lone pair, or the shared pair as a line, and that's F2 right there. So when you see this, the dots are the unshared pairs, and the line is that's your shared pair right there. Excellent. So electrons in Lewis models, we have bonding pairs and we have lone pairs. Bonding pairs are when your electrons are shared between two atoms. We'll represent these two electrons with a line, so one line equals a bonding pair of electrons. Then we also have lone pairs. These electrons are only on one atom, they're not between atoms, so we'll represent these two electrons with two dots. So the line will represent a bonding pair of electrons, like that, and two dots will represent one lone pair of electrons. So when we're doing Lewis dot diagrams, there's a couple of rules here. The central atom is the least electronegative. It's the atom with the smallest number of valence electrons. It is usually be an oddball element. And it's a central atom, can never be hydrogen. We're going to use what we call the NOSBU method, and each of these letters is something important to us. And this will work for atoms that obey the octet rule, and it gives us the number of bonded and lone pair electrons. So first, needed. Most everything needs 8 unless it's hydrogen. Available. How many valence electrons are there? Shared. You get this by following this formula. Needed minus available equals shared. And then bonds. Bonds, this actually is not on your note sheet, but please add this. What you do is just basically take your number of shared, divide by 2, and it gives you your number of bonds. So if you have 4 shared, divide that by 2, you have 2 bonds. And then unshared, use this formula, available minus shared equals unshared. We'll use those over and over again as we do the drawings. So our first drawing is for HCl. HCl, we know hydrogen has 1 valence electron, chlorine has 7. Hydrogen needs 2, chlorine needs 8. So if we look at the number that's needed, the number needed would be 2 plus 8, which would be 10. Number available would be 1 plus 7, which is 8. To do shared, remember it's needed minus available, or 10 minus 8, which is 2. Divide 2 by 2, it gives us only one bond. And then 8, or available minus shared, 8 minus 2 gives us 6 unshared. So now what we do is we want to draw this molecule. So we say we've got H, and then combine that with a Cl, and that's our shared, our one pair, our one bond. And we have 6 unshared, so we're going to put those in the chlorine because hydrogen only needs a duet. So 2, 4, 6, and then the shared pair gives us, so we've got 8 on chlorine, 2 on hydrogen. Perfect. Let's do another atom. Let's do ammonia. Ammonia is in H3. Each hydrogen has 1 valence electron. The nitrogen has 5. Each hydrogen needs 2, and we've got 3, so that's 6. And the nitrogen needs 8. So to do the needed for this would be 6 plus 8, which would be 14. Available for this would be what we actually see there, the 5 plus the 3, which is 8. And shared would be 14 minus 8, which is 6. And divide that by 2 gives us 3 bonds. And then we say available minus shared, which would be 8 minus 6, would be 2 unshared. And so to draw this, you would put nitrogen as a central atom, combine it with 3 hydrogens. 1, 2, 3 hydrogens. And there you have your ammonia, and you put the lone pair on nitrogen. So that's how you draw ammonia. And there's another drawing, or a line like that. So you can see you got the NH3 there. Nice job. Number of electrons around each atom. Nitrogen has 8, it's stable. Hydrogen has 2, it's stable, and you're set. Next we're going to draw, I believe, water. Yes, actually H2O. For this, we see hydrogen needs 2. 2 times 2 is 4. Oxygen needs 8. And that gives us total 12. Available, there's only 2 available, and oxygen only has 6 available, so that gives us 8. 12 minus 8 is 4. 8 minus 4 is 4. That's so 4 shared, 4 unshared, and divide that by 2, that gives us 2 bonds. So the way you draw this, you do oxygen, forms 2 bonds, one with hydrogen, another with hydrogen, and that takes care of your shared electrons. And now we have 4 that are unshared, 2, 4, 6, 8, and there we have the drawing of water. See a little bit better drawing here. So there's H2O as a molecule, and then we draw it with the structural formula with the lines. Let's do methane. Methane CH4. If you're flatulated, that would be methane. It's a flammable gas. Methane, the hydrogens all have 1 valence electron. Carbon has 4. And so now we want to do the NOSBU for this. And so to do this, we know needed. So we each one of these has they need 2 times 4, which is 8, and then you need 8 here. So 2 times 4, so that would give us a total of 16 that are needed. Available, we just count. We've got 4 plus 4, so we've got 8 there. 8 available. 16 minus 8 gives us 8 that are shared. 8 divided by 2 gives us 4 bonds, and 8 minus 8 available minus shared gives us 0 unshared. So the way this will look is you'll have a carbon, and you're going to have 4 hydrogens around it. And notice when you do this, the carbon actually has 8, 2, 4, 6, 8. Each hydrogen has a duet, so it's stable and happy. Let's go through the rest of this. There we draw the methane, and there you go, CH4. Excellent. And let's do another drawing here. I think we have maybe our last one. This is our last one. This is CO2. Carbon has 4 valence electrons. Oxygen has 6. We've got 2 oxygens. So needed, all these need 8, so we can just say 8 times 3, which is 24. available. Let's count how many we got available. We got 6 times 2, so we got 12 here, and 4 here, so we got 16. To do share, we have 24 minus 16, which would be 8, which would be 4 bonds. And then the unshared would also be 16 minus 8, which is 8 as well. Now what's interesting here is we see we've got 4 bonds, we only have 3 atoms. What atom goes in the center? We want to put the least electronegative in the center, so that's going to be carbon. So we put carbon in the center, and then oxygen on each side. Now what's interesting is there we've only formed 2 bonds. This says we need to form 4. So we're going to make these double bonds. Now we've got double bonds between oxygen and carbon, and we're going to use these 8 unshared electrons. So right now carbon has 8, 2, 4, 6, 8. Each oxygen only has 4. So to give it 8, we're going to put a shared pair, or lone pair, and another lone pair. So now that oxygen has 8. We'll do the same thing with the other oxygen. 2, 4, 6, 8. So now everything has 8. So that's how you do CO2. Let's go ahead and finish it out here. CO2 like that, or you can draw CO2 like that. And that'll be it. And so you got 4 electrons. That's the end.